In this lesson we're going to look at what is called the effective resistance, and this is sometimes known as the equivalent resistance in a circuit. So there are some situations where we need to do circuit calculations where there are two or more resistors or resistances present in the circuit, and what we have to do in order to make those calculations is to simplify the circuit. So in this first case here we've got a series circuit. We've got three resistors in series. Let's call them R1, R2 and R3, and we need to replace those three resistances in series with one single resistor, and that's really easy to do that. So we can say that the equivalent resistance, which we call RE, not surprisingly, is simply equal to the sum of those resistors in series. So this could go on and on. In this case we've just got three, and it's R1 plus R2 plus R3. Okay, so what we've done is we've replaced this circuit here with this one, where we have one single effective resistance or equivalent resistance, RE. Okay, so let's just put some figures into this. Supposing we have, say, a 24 volt battery and we have three resistances here. Say R1 is 3 ohms, 4 ohms and 5 ohms. And we want to calculate the current that's flowing in the circuit. So we first of all find the effective resistance, we add those up together, and that comes as 12 ohms. And we've got 24 volts here. And then using Ohm's law, that's V equals IR, we can calculate, where R is the effective resistance in this case, we can calculate the current. So I equals V over RE, which equals 24 divided by 12, which is 2 amps. So we now know that we have a current of 2 amps flowing around this circuit. Okay, let's look at a more complicated situation now where we have resistors in parallel. Right, so we'll just look at two resistors in parallel. Here we have R1 and R2. Now this time the relationship between the effective resistance and the actual resistances in the circuit is this one. It's 1 over RE is equal to 1 over R1 plus 1 over R2, and that could go on and on while you're adding resistances in parallel. So it could, if you have 3, 4, 5 resistances in parallel, then it will be 1 over R1 plus 1 over R2 plus 1 over R3 plus 1 over R4, etc., etc. We've just got 2 here to keep things simple. That's our effective resistance relationship. So what we've done here is we've replaced R1 and R2 in parallel with this single effective resistance or equivalent resistance, RE. And now we can calculate the current flowing around this circuit through this ammeter. To help us understand this a little bit better, let's plug some numbers into the situation. So we'll say that R1 has a resistance of 4 ohms, R2 has a resistance of 6 ohms. Again, we'll use our 24 volt battery again, and now we've got to calculate the value of RE. Let's do that. I'm going to move over here to make a bit more space. So we remember our relationship, 1 over RE was equal to 1 over R1 plus 1 over R2. We plug our values in. 1 over RE equals 1 over 4 ohms plus 1 over 6 ohms. Okay, basically we need to add these two fractions together, find the lowest common multiple, which is 12, and then 4 into 12 is 3, then 6 into 12 is 2. That gives us 5 over 12. Okay, now that is the reciprocal of RE, this value. So what we need to do now is invert this. If we invert this side of the equation, then we need to invert that side of the equation, as you well know. So that gives us RE over 1 equals 12 over 5. And you also well know that RE divided by 1 is RE. So that comes out as 2.4 ohms. So going back to our equivalent circuit, with the effective resistance, we can say that that value now is 2.4 ohms. And so we can use Ohm's law again to calculate the current. Remembering again, V equals I times RE. So I equals V over RE, effective resistance, which is equal to 24 over 2.4, which is equal to 10 amps. So we've now calculated that flowing around this primary branch of the circuit, we have a current of 10 amps flowing. What will happen when it reaches this parallel part here is that current will divide up into 6 amps going that way and 4 amps going that way, remembering that the sum of these two currents must be equal to 10 amps, and these will then join back again when they come this way to form 10 amps flowing back into the battery. Okay, so that's how we calculate the effective resistance of resistances in parallel.